All right, so in the previous modules, we've looked at plastic properties and how we define things like ductility, strength in terms of either tensile or yield strength. And so now let's put that into practice and do a couple examples. All right, so there's going to be two examples, and I just want to go over what those are, and then I'll have you stop the video and then go answer them on the quiz, if there is one for the week, or just do it on some piece of paper, and then pause the video and come back after that, and we'll work through these two examples. So the first question I have for you is, given the stress-strain plot here, what method is to be used to determine the yield strength for this type of material? So you just have to tell me what method. So once you've done that, I want you to approximate the tensile strength and ductility for the same material, the same stress strain plot, given that it initially measures 8.5 millimeters in diameter and 80 millimeters in length. So answer those two questions, and then we'll come back and we'll work this together. All right, so let's look at the first question. What method is used to determine the yield strength of the material below in the engineering stress strain plot? So when we're looking at this, we know two ways to determine yield strength. We either do it by the lower yield point if it's the yield point phenomenon, or if it's a gradual transition, we use the offset method. And so in this case, I don't see an upper and lower yield point. All I see is a gradual transition from linear to nonlinear. So that would tell me it's gradual. So let me go back to those slides just so that you can see what we're talking about. So these are the kind of the two types that we can have of yield point phenomenon. The normal or gradual, and then the yield point phenomenon. So the one we just saw in the plot is like this. And so we're going to need the offset method, right? So we're basically, if we want to do this, we would construct a line with the slope of the elastic modulus, offset that line as you see here, and then determine where it intersects on the stress axis, and that's our yield strength. So that's the method we would do, the 0.2% offset method, in order to determine the yield strength. And so let me go back to that for you. All right, so that's what we would need for this, because again, it looks gradual, and so we're going to do the offset method for this sample. All right, let's look at the other question. So it wants us to approximate the tensile strength and ductility. Okay, so let's take that part by part. So tensile strength, right? If you remember from the previous module, is the maximum value of stress on the curve. So you can see it's somewhere up here, and it's the stress value that's maximum on this curve. So if I just draw a line from where the maximum is, and I kind of go over here, I see that the tensile strength is somewhere around 1,950 megapascals, right? That's my tensile strength, or ultimate tensile strength. So that's how I get the first part. The next part it's asking for is ductility, and it gives us the initial measurements as well. So if you remember, ductility can be measured by percent elongation or reduction in area. The curve, the strain, is always going to be an axial strain, not lateral. And so this is going to be related to the length. And so the strain value at failure, which would be this point right here, if we go down, we see that the strain there is about 0.076 approximately. So percent elongation is defined by the change in length over the original at failure. The F refers to failure, which is this point right here. So this point, or this portion, is just strain, right? It's the strain at failure. And the only difference is we multiply it by 100. So if we take that 0.076 and multiply it by 100, we get 7.6%. That's the percent elongation at failure. So that's important to know. That's the ductility. That's the measure of the ductility for the sample. So these two are pretty straightforward to obtain from a stress strain plot. We can also talk about others, but I just wanted to show you an example with ductility and tensile strength.